A gives B as many cents as B has and C as many cents as C has. Similarly, B then gives A and C as many cents as each then has. C similarly then C gives A and B as many cents as each then has. If each finally has 16 cents, with how many cents do each of them start? So you start with A becoming A minus B minus C, B becoming 2B, C becoming 2C. So then you get A to be 2 times A minus B minus C, B to be 3B minus A minus C, 4 to be 4C. And then A finally becomes 4 times A minus B minus C, B becomes 6B minus 2A minus 2C, and C becomes 7C minus B minus A. Set them all equal to 16. So then you have your three equations, and you're using process of elimination to try to narrow them down to figure out each of them. So I have first two equations, and I have minus 2a plus 6b e minus 2c equals 16, minus 2a plus 2b plus 2c equals negative 8. Use process of elimination in it to get rid of these. Minus 4a plus 8b equals 8. And then with these right here, you have 7a minus 7b minus 7c equals 28. Negative a plus or minus b plus 7c equals 16. Use process of elimination to get rid of the c's again. 6a minus 8b equals 44. So I have minus 4a plus 8b equal to 8 and 6a minus 8b equal to 44. I add, getting 2a equal to 52. So a then equals 26. Plug a, say, back into this equation, and 26 times 6 equals 36. Carry the 3, 156. So I could find the negative 156 minus 44. This should equal 8b. E is 112. 112 divided by 8, 132. So b equals 14. And then to make things a bit easy, I am going to plug those in to there. There 4 times, and it's 26 minus 4 times 14 minus 4c equals 16. So then, timesing by 4, 24, carry the 2, 104, minus 16, carry the 1, 56, minus 4c equal to 16, 104 minus 56 equals, turn that into 0, 9, 48, so 48 minus 4c equals 16. Subtract 16 from both sides. 32 minus 4c equals 0. So c equals 8. So I get a equal to 26, b equal to 14, and c equal to 8. And that is number 7. So then lastly, on to number 8. Town A and Town B are separated by a river, or as in the picture, or as seen here. Town A is located 30 miles from the river, and Town B is located 60 miles from the river. The vertical distance between towns A and B is 120 miles and the river is 10 miles wide. A road is to be built joining A and B, crossing the river on a bridge. If the bridge must be perpendicular to the river, and the road is to be as short as possible, find the location of the bridge and the length of the road. So in the diagram, I'm going to try and make this easy as possible. I have 30, I have 10, and then I have 60 and 120. Now, drawing is not drawn to scale. Oh, but if I take out the river, then I have 90, 120, and then I have that, which I'm trying to solve for. So then, you're taking the square root of 120 squared plus 90 squared to get at this distance. 120 squared, 0, 0, 4, 2, plus 0, 0, 0. No, because 0, 0, and that's 0, 2, 1, 0, 0, 4, and then 90 squared. I don't have one. 90 squared equals 5,400. And then when you take the square root of adding them together, you would get 150. And then you would have to then add back in the 10 to get the distance to equal 160 for the total of this. Then you want to try to find the length of this part right here. And in order to do that, you would take the derivative of 9 plus x squared square root plus 12 minus x squared plus 36 all under the square root. And this is if you divided everything by 10, which would get you to 4, but because I divide everything by 10, I need to multiply. Because when you set the derivative of this equal to 0, that gets you 4, but I multiplied everything by 10, or divided by 10, so I need to multiply, which gets you 40, so the length of this is 40. And there's my answer.